My name is Kenneth Segarra, and this is Physics 2325. And now I'll be explaining our project. In this project, we're trying to calculate the tension, the angular acceleration of the wheel, the translation acceleration of the object, and the speed in which the object hits the floor. We will be calculating this by measuring the mass and the spinning disc, and drive mass by calculating the time it takes the object to hit the floor. Having all this information, we'll be using this constant acceleration formulas to find the values that we're missing.
Hello, my name is Cipriano Rivera, and for our project I'll be explaining rotational motion. Rotational motion is motion in an object's center of mass where every point in the body moves in a circle around the axis of rotation. The center of mass is the point in an object from which there is an equal amount of mass in any two opposite directions. Go.
Okay, I'm going to explain the calculations right now that we did. First, we're going to find tension. And tension, we're going to use the formula of torque, which is force times distance. And force here will be tension, and torque here, we could also equal it to I alpha. So we're going to equal distance times tension equals I alpha. I equals 1/2 mr squared, and alpha equals A over distance radius. Here, we're going to cancel out the r's right here, so it's going to be 1/2 mr_a. And then we're going to bring the r over here, which will cancel out this r, so it's going to, tension is going to equal to 1/2 ma. Then, to find acceleration, we're going to go over here, equal this to tension, which is mg minus ma. We're going to move here and equal to leave ma alone. And over here we're going to try to get acceleration by itself, which we move everything over here is going to equal to 2 mg over big M plus 2 little m. And then with our calculation that we got, we're going to plug it in, which will get to 0.79 meters per second. And then with this acceleration, we're going to plug it into this formula right here, which we get 1/2 times 0.366 times 0.79, which our text is going to equal to 0.1445 with 7 newtons. And then here we have tension. Now we're here, we're going to try to find angular velocity, which angular velocity we could equal it to 2 pi over time. Our time we got 0.72 seconds. So if we divide these two, we're going to get to 8.73 rads per second. And with this, now we could find angular acceleration, which angular acceleration equals to angular velocity over time. Our angular velocity over our time will equal to 12.13 rads per second squared. And from there, we just have to find our speed of the object, which equals velocity over height over time. Our height was 0.18 meters, and our time was 0.72 seconds. When we divide those, the velocity for the object is 0.26 meters per second. And finally, we have to find acceleration on the tangential angle. Here we have a formula, and we're going to plug in our values that we got. And with the values, we get 36 rads per second. Thank you.
Alright, in continuation with our rotational project, this is our contraption that we made it. This is made from a old VCR. I just disassembled most of it and just ended up with this frame. We're going to be using this the rotating head and this electric motor as our pulley. As a demonstration what we did to do our calculations, I'm going to roll it up. The string has a pair of keys to add our weight, and it's already recorded the weight. We're going to let it drop, time the drop, and the length of string that was used, and we'll be plugging them in our calculations.